So welcome to this particular lecture on the nuclear models, right? So in this particular lecture series, we will develop the mathematical theory, the physical ideas of the different nuclear models, right? So this is the lecture just to introduce you what the nuclear models are and why do we need them and what are the different type of nuclear models and so on. So just to give you idea, just to introduce you about the nuclear models. So basically, we just want to know about the structure of nuclei as we are interested in the structure of atoms because as a human being we are interested in the fundamental building blocks of the universe. So we are just digging deep down as we can. And now the question is what the nuclei is made up of, and that question is not that simple because it is not that easy to do experiments with that very small object which is of size 10 to the power minus 15 meters. So that is what the typical radius of the nuclei. So that is just very small object. So it is very difficult to study the internal structure even of that particular nuclei. So we are just going too deep. So the main aim is just to know the basic structure of nuclei, right? What it is made up of, how the constituents of nuclei are living in this particular space, right? How they are radiating energies and so on. The questions like that, right? So we are interested in the distribution of nucleons, right? What are those are the protons and neutrons inside the nucleus, right? And these are the questions that we are looking the answer for. And nuclear model are the things which we develop to answer these particular basic questions about the structure of nuclei, about the distribution of nucleons in the nucleus, about the interaction of nucleons in the nucleus, right? The force between any two protons, neutrons, and proton neutron. That particular force, even we don't know the real structure, the exact structure of that particular nuclear force. That is even very difficult. We know the structure of atomic force, which is the electromagnetic force, right? We all know uh, we just have studied electromagnetic force in detail, right? We know so many properties of that particular force and how particles which are interacting via electromagnetic force, we know about them very much, but about the nuclear force it is not that easy. So we are interested in that particular question, the exact form of the nucleus, of the interaction between nucleons, right? And these are the models, the theoretical models that people have proposed to just give answer to this particular questions, right? This is just the basic motivation behind the nuclear models, right? Why we are interested, because we just want to know the structure of nuclei, and uh, it's just things happening in the nucleus. So the most useful and basic models that we start studying in nuclear physics are just these three. These are the most basic and useful models. It is not that they are just the only one. We have many other nuclear models, but these are the basic models that we have. The liquid drop model. You all have studied that model in your school physics also, but we will just elaborate in detail that model, right? So the first few lectures will be about the liquid drop models, right? What are the basic assumptions and why people think that nuclei are like the drop of a liquid. So the questions like that, because if they are thinking that we can assume nuclei as the drop of liquid, so there must be some motivations behind that, some physical benefits of assuming nuclei as the liquid drop. So we will see those assumptions, right? And we will see the implications of assuming nuclei as the drop of a liquid, right? And it is very interesting model because this model was able to explain the variation of nuclear binding energy with the mass number of the nuclei. It is the model which is very successful in explaining nuclear fusion of heavy nuclei. And but this particular model is not of that big success because we will not be able to calculate the exact value of spin of nuclei, the magnetic moment of nuclei, the stability of some nuclei which has some magic number nucleons, which are the number of protons or neutron if it is 2, 8, 20, 50, 82, and 126. So these are some basic magic numbers for which the stability of nuclei is very high as compared to the other nuclei. So this model was unable to answer this particular question. So that is what the limitation of this particular model is. And we will discuss the second famous model, which is Fermi Gas Model. And this model will assume the protons and neutrons inside the nuclei as if they are just the free gas, right? Inside some in some particular bound space, if protons and neutrons are moving freely like a gas, we will assume neutrons and protons to be the gas particles. And because we know that neutrons and protons are fermions, so in a Fermi gas model, we will use the Fermi Dirac statistic to calculate the energy level and so on, so that we can compare the predictions, the theoretical predictions with the experiments, right? So that all calculation we will do in the lectures on the Fermi gas model. It is just the introduction part that what we are going to do in this particular lecture series. The last one and the most useful and famous and successful model is the nuclear shell model, right? So as we know, in the atomic structure, we have assumed that there is some kind of cells, electronic cells in the atom. So just in the same manner, we will assume the shell inside the nuclei, and we will assume that the nucleons are distributed in these particular cells inside the nuclei, and we will calculate different properties like magnetic moment of nucleons, the electric quadrupole moment, and spin of the nuclei and things like that. And the interesting thing is that this particular model gives a very successful results, right? The results which has been compared with the experiments, and it is very precise model. But again, it has its own limitations, and there is no single model we have in the nuclear physics which is able to explain all the nuclear properties. So these are different models, and they have different limitations, advantages, right? So we will study the basic assumptions behind the model, the advantages of the model, and their limitations. So this is what we are going to do this in this particular lecture series on the nuclear models. So I hope you will enjoy this particular lecture series. So thank you for this.